How about parallel versus perpendicular? See what you remember about this. Parallel is easy. We'll warm up with parallel. If two lines are parallel, how are their slopes related? They have to have the same slope or they would cross at some point, wouldn't they? Right? So yeah, the parallel lines have equal slopes. This is the tricky one. What about perpendicular lines? They intersect at a right angle, but what can you tell me about their slopes? So one has to be positive and one has to be negative. That's for sure, right? If two lines are going to be perpendicular, if one of the lines is increasing, the other one would have to be decreasing, right? True, but there's more to it than that. Well, opposites means they have different signs. That's true, they're opposites. What else, though? There's another part of that. Let's look at an example. So if we just make them opposite, look what happens here. Okay, there's two lines, y equals 10x plus 3 and y equals negative 10x minus 1. Okay, well, those are opposites, but that's not enough. Those are clearly not perpendicular. Oh, whoops. Okay. The red one has a slope of 10, blue one has a slope of negative 10. Clearly not perpendicular. What else do I need to do? True, but really we don't care about the y-intercept. Y-intercept is irrelevant. Let's make this one like 2/3, how about? And let's make this one negative 2/3. Oops, that's negative, negative is positive. There we go. Okay, again, close but not perpendicular. Think about that. Think about the road map an ant is taking to walk on the red line. He's going to rise 2 for every 3 that he runs. If I want to do something that's perpendicular to that, yeah, it's going to be an opposite reciprocal. What if I do, aha, look at that. Those are perpendicular, aren't they? So they have to be opposites, so one line increases while the other line decreases, and the slopes need to also be reciprocals to be at 90. Okay? Is that ringing a bell? Remember doing that? Vaguely? Okay. So we know then slopes of perpendicular lines are always opposite reciprocals. Have to be both. Opposite signs and the fractions need to be flipped. So let's look at a couple quick examples here. What about number 15? I've got the left, the two lines. What about the first line? The equation on the left, what would I have to do? How would I know? How would I test to see if these lines are parallel or perpendicular or neither? What would I do? Plug them into what? Well, we don't have Desmos on the test. What are you going to do?
Plug them into the original slope of each equation.
Oh, okay. If I knew the slopes, I'd be set, wouldn't I? Because we know that in order for lines to be parallel, the slopes would have to be equal.
Yeah.
For them to be perpendicular, they would have to be opposite reciprocals. Okay, how am I going to find the slope? What do you mean solve it? There you go. How about that? We could isolate y because isolating y puts these into slope-intercept form. Y equals mx plus b. And the slope would end up just being the coefficient of x on the other side when I simplify it, right? That's a great way to do it. So put it into slope-intercept by isolating y, and then just by inspecting the equation to see what the coefficient of x is, we can determine the slope of each line. Okay, let's try that. So negative 8x plus 8y equals 0. What are the steps to get y by itself? Add 8x. And then what? Divide by 8, and I get y equals x. So what's my slope? 1, because the coefficient of x is 1 there, right? Okay? So m is 1. What about the other line? What would I do? Subtract x, then what? Divide or multiply by -1 to change all the signs. And so I'd get positive y equals x minus 4. So what's my slope there? Yeah, my slope is 1, so they are parallel. Because the slopes are equal, we know they're parallel. Okay? How about this next one? I don't know what number it is, but first equation, what do I do just to isolate y? Subtract 9x, then what? Well, I mean, I could, but I'm just trying to get y by itself, so what would I? Divide by -6. Okay, so now let's look at that. If I divide by -6, let's look at that math real quick. -6y equals -9x minus 20. Okay, we're going to divide each side by -6, but that gives me a common denominator on the right. I don't really want a common denominator, do I? I want to split those fractions up, which is no big deal. How do I split fractions? I just make two different fractions, right? I divide each term by -6. So I end up getting y by itself equals -9x over -6 plus -20 over -6. Okay, well, whatever I get that's being multiplied by x, the coefficient of x, is going to be my slope. So what's my slope going to be? Okay, well, that reduces to 3/2. Yeah, so I get the equation y equals 3/2 x plus, who cares? Because all I care about is the slope, right? I'm just trying to determine if these lines are parallel or perpendicular or neither. So there's my slope. What about the other side? What would I do? What's the only thing I have to do here? Divide by -3. That's going to give me y by itself. What am I going to get on the other side? -2/3 x plus, who cares? Right? I know that my slope for the other line is right there. So what can you tell me about those two lines? They are perpendicular because they are opposite reciprocals. Okay, one more. How about number 13? What would I do on the left side? Okay, is that going to work? Let's see. Yeah, let's do that. Okay, so we subtract 10x, so I get 5y equals -10x plus 5. Next step. Okay, that gives me y equals what? -2x plus, who cares? 1, but not that we really care, right? That's my slope. How about this other line? What do I do? Subtract 16. I'm going to flip them around so the y's on the left side. So I get -x minus 16. Everybody agree? And then divide by 2. And I get y, let's do it in red. Y equals negative what? 1/2 x minus 8. So what can you tell me?
Perpendicular.
Perpendicular?
Oh,
They're both negative. Yeah, okay. So parallel, perpendicular, or neither? Neither. There you go. Neither. Okay. We're getting there. Quickly. What's the equation of that line? X equals or y equals? The slope is 0, Show me with your arm what that looks like. So is a horizontal line named by its y coordinates or its x coordinates? Y. It has all the same y coordinates. The easiest one to think of is the y-intercept. In this case, the easiest one to identify is that guy, right? So it's just y equals -5. Why is it y equals? Because it's horizontal, right? Okay, that line is in slope-intercept form. What's the slope? Zero. Right? How do you know it's 0? Well, what's the coefficient of x in that equation? If there's no x, what must x be multiplied by? Coefficient 0. There you go. So the slope is 0. Okay. How about that one? Show me with your arm what that looks like. Okay. What coordinates are all the same?
X.
X. So it must be an x equals, right? X equals what?
-4.
There it is. Piece of cake. All right, last issue for today. I'm going to turn you loose. X and Y intercepts. So you guys all know what X and Y intercepts are. We all know that an x-intercept is a place where a line, or it doesn't have to be a line. For now, we're talking about lines. So a place where a line intersects the x-axis, crosses the x-axis. Y-intercept is where the line crosses the y-axis. So what are the coordinates of the x-intercept? -3, 0. You bet. Because we know that it has to have coordinates. I guess it doesn't do that. It has to have coordinates, a y coordinate of 0 to be on the x-axis, doesn't it? Right? To be on the x-axis means, what does it mean? What do the coordinates of an ordered pair really represent? They're just giving us a roadmap from the origin. How would an ant get to that location, right? The x coordinate tells us how far the ant's going to move horizontally. The y coordinate tells us how far the ant moves vertically to get from the origin to some point. Well, if it's on the x-axis, the ant can't move vertically at all, so the y coordinate has to be 0, right? Makes sense. What are the coordinates of the y-intercept? 0, +4. Good, and we know the x-coordinate would need to be 0. Okay. All right, last issue. Really good little trick here. So we know that x-intercepts always occur where the y-coordinate is 0, right? So if I have some equation, can anybody think of a really sneaky shortcut for finding the value of the x-intercept? Yeah, right? We're just trying to ask the math gods, what's the x value when y is 0, correct? Isn't that what we're doing? That's the meaning of the x-intercept. Well, how do we ask the math gods that question? What's the value of y or value of x when y is equal to 0? Well, we just set y equal to 0 and the math gods answer us with an equation. So there it is. Set y equal to 0 and solve for x. Fair enough. If I want the x-intercept, I'm setting y equal to 0, correct? This is a great little trick. It's called the cover-up technique or cover-up method. You're just going to set y equal to 0 and solve in your head for x. What are the 2 steps to solve for x? So what do you get? -25. Done. Easy, right? Whoops. Okay, well now, what would my corresponding strategy be for finding the y-intercept? Set x to 0 and solve for y. We can do that. Set x to 0, and that's pretty easy. What's y equal to?
50.
There you go. Right. Set x to 0, and y is 50. Okay. And the math you guys did in your head is, you don't. That's it. But it is math, simple math, solving two-step equations that you can just do in your head. Okay, so let's try a quick example, and I'll turn you loose and let you guys work on this. So I want to find the x and y intercepts in order to graph this equation, because what's always our strategy for graphing a line? 2 points, connect and extend. Well, why not make those 2 points the x-intercept and the y-intercept, because they're so easy to find? Okay, let's find the x-intercept. What do I do? Okay, good. I'm going to set y to 0. And solve for x. Fair enough? What's x? 15. So 0, 15, that's out, what do you think, right about there? Okay. Good enough. What do you think it was, 14.9? Okay, that's, yeah. Question?
Should it be 15-0?
I mean, 15-0, you're right. Yep, whoops. Thank you. Good. Okay, what about finding the y-intercept? What would I do? Set x equal to 0. There you go. And solve. Okay, well that just means covering up the x term and solving. What's the answer? -6. So 0, -6 is right there, and then all I have to do is just connect and extend. And there's my line. How about that? Good? Okay, you can go to work. There are 2 assignments up there. Have at it.